Okay, lesson 4.2, applying congruence triangles. Identify congruent figures. Two geometric figures are congruent if they have exactly the same size and shape. They have to have the same size and shape. So each one of these red figures are congruent to the other ones. Look at them. They're just turned, slid over, but they're all exactly the same. Please write down what is written in blue. Two geometric figures are congruent if they have exactly the same size and shape. You can pause at any time. In this next one, none of the blue figures are congruent to the other blue figures. Look at them. They're either all different sizes or they're even different shapes. Now we're going to identify congruent figures. When two figures are congruent, there is a correspondence between their angles and sides, such that the corresponding angles are congruent and corresponding sides are congruent. So you're going to write down the triangle, this congruent statement, triangle ABC is congruent to triangle PQR, which remember we referred to it before as a congruent statement with line segments and angles. Now we're using triangle. Notice the notation for triangle is a little triangle. Triangle ABC is congruent to triangle PQR. Draw these two figures. ABC, PQR. Please mark up the triangles as they are marked. Notice A and P both have double marks. B and Q each have a single mark. C and R each have a triple mark. Then let's look at the sides. AB has a single tick mark. PQ has a single tick mark. BC has a double tick mark. QR has a double tick mark. And then of course AC has triple and PR has triple. Now look at your statement above. A, B, C. A is at the very beginning. Notice in the picture it has double. Now look at what it's congruent to. P, Q, R. P is at the front. In the picture, P has 2. B in the first has 1. Q has 1 in the statement. In the statement, C has 3. R has 3. And they're both at the end. This is where the statement must match the triangle marking. So if A is congruent to P, then you must start with A and P, and so forth. Let's list the corresponding angles. You can do it by the picture or by the statement, because A is at the beginning, so therefore P is its congruent angle. B is the second, so Q is the congruent angle. C is the last with 3 tick marks, so R also has to be the last. And then we can list the corresponding sides the same way. AB is at the beginning, so guess what it matches with? PQ. BC is the last two, so it matches with QR. AC is one in the beginning, one at the end, so therefore it matches PR or RP. Those are congruent sides and angles, but when they ask you to write a congruent statement, you just write triangle such and such is congruent to triangle such and such. Now there is more than one way to write a congruent statement. We could have written it backwards. CBA is congruent to RQP. You could also mix up the letters as long as they match the second one. So I could have started with B and then did C and then A. The only thing you have to do is make sure it matches. B goes with Q, C with R, and A with P. Here's an example. The two triangles shown below are congruent. Write a congruent statement and then identify all pairs of congruent corresponding parts. Take a moment if you have to. Now this is just one solution. It all depends how you begin your triangle. If I started with FED, F has a triple, I would have started with T. E is a single, then I would have went with S. D is 2, then I would have finished with R. So my statement would have been FED is congruent to triangle TSR. Now on my example on the PowerPoint, I started with D. D is double. It matches with R, which is double. E is single. It matches with S. And F is triple. It matches with T. The angles for the first one, just look at the letters. You don't even have to look at the picture. D goes with R. E goes with S. F goes with T. The sides do the same thing. The first two letters are DE. It matches the first two letters of the other, RS. EF are the ending, so it matches ST, the ending. And then don't forget the last one. First and last DF goes with first and last RT. Here's another example using properties of congruent figures. So you have the diagram MPLM is congruent to EFGH. Now remember, it still works for others than triangle. We're going to find the value of x. So look for x on your picture. It's located at GH. So GH is the last two letters of the statement, so it's going to correlate to LM, the last two letters. So we could state 2x minus 3 equals 8x because congruent means equal. Now we just solve. Add 3 to both sides. Divide by 2. So there's your x answer. Now let's look for y. Notice that y is located at E. Well, E in the statement is the first letter. It matches with N, so they are equal. Now we just subtract 9 from both sides and divide by 7. That is your answers. Now we're going to talk about transformations. Transformation is when we have congruent figures, such as triangles, that can reflect. That's like flipping over a line. Translate, that's moving. We're just gliding here and there. And rotating is still you're turning. But they all still stay congruent because we didn't stretch them out. So here's a triangle. Here it goes doing the reflection. See, it reflected from the bottom up. Now we're going to go back to our original. And we rotate it. Rotating is where you turn it. And usually you only turn it 90 degrees clockwise or 270 counterclockwise. 90 clockwise is going to the right one turn. Counterclockwise is going to the left one turn. Okay, so now we're going to find angle. We're going to find x. Now notice the markings in the picture. The double marking N goes with R, so they're congruent. L has a single marking, it goes with S, so they're congruent. Well, that doesn't help us solve this because we can't set an equal. But according to the third angle theorem, if N is congruent to R, L is congruent to S, then M is automatically congruent to T. And what do the angles all add up to equal? In a triangle, 180. So we're going to take 55 plus 65, subtract them from 180, which is 60, and then use our third angle theorem. So M, which is 60 degrees now, equals T. So therefore, we set them equal to each other now. And there's your answer.